you all for coming. As mentioned, my name is Paul Murphy, and I'm a developer at Mimus. Mimus is a centre of excellence based within the Faculty of Humanities here at the University of Manchester, and it hosts a number of research data services that are funded by JISC and the USRC. The particular service that I work for is the international arm of the Economic and Social Data Service, and that distributes international aggregate data sets, the type that you get from the OECD or the World Bank. So, as mentioned, I'm going to talk about linked data, but before we talk about what linked data is, we need to take a bit of a step back and talk about what the web is as it currently stands. The web is essentially a collection of documents, a lot of documents, and these documents are all linked together. But the important point is that they're not data, they're documents. And you might wonder what the difference actually is, but documents have a number of problems with them. Documents are containers of data, they're not actual data themselves. So if you've got a document, you can read it, but that's pretty much all you can do with it. Whereas if you've got data, you can do an awful lot more. You can read it, but you can also edit the data, you can manipulate it, you can visualize it, you can build applications on top of it, and all sorts of other interesting things. Now, we humans are relatively good at navigating this web of documents, but machines are not so good. And they're not so good because they don't understand what the documents are actually about. They can display them to us, but they don't understand the meaning. They don't understand the semantics that are within the documents. And the other problem is there are so many of these documents that it can be difficult to find the information that you want. And also, once you've found the document, you then have to locate the data that you're looking for within that document. So if I can give you an example of this, the Olympics are nearly upon us and the evening is starting to get lighter, so I might optimistically decide I'm going to run a marathon. So I look on the internet for information about marathons. But I put marathon into Google, and Google doesn't know what I'm talking about. It can find all the pages, but it doesn't actually know what I want to know about. And the term marathon can mean many different things. So it could mean the sport, marathon running. That's not me, by the way. That's Fallujah Singh, who's the first centurion to complete the marathon. But it could also be the place in Greece, or it could be the computer game, or it could be the 1980s chocolate bar. The computer doesn't know which one of those marathons I'm talking about. So what I want the machine that I'm talking to actually do is do what a human would do and try and probe me for more information and find out what type of marathon I'm interested in. So I want it to ask me, well, what do you mean? Do you mean the sport, the town Greece, the computer game, or the chocolate bar? What it actually does is this. It returns all 35 million pages that mention the word marathon and expects me to sift through those pages and find the information that I'm looking for. Now, obviously, this isn't the best way of going about finding data. And Tim Berners-Lee, who was the person who invented the internet, realized that this is a problem. And as the internet gets ever larger and more data gets on it, it becomes ever more so a problem. So he realized that in order to make the internet better, we need to add meaning to it and get the computers that we're trying to interrogate to understand this meaning. And he also realized that there's a huge amount of potential that's locked away inside documents and inside data sets that we don't have access to or we can't easily interrogate. So he came up with this idea of a semantic web, a web that understands what we're talking about when we talk to it. Now, the way of achieving this is through something called linked data. Now, linked data is about three things. It's about making data freely and openly available on the web, and that means liberating it from the documents and databases which contain it. It's about using unique names for things so that everything can be referenced. And it's about making links between data and describing the relationships between data. And by doing that, we add context to it and we make it machine understandable. Now, the easiest way to explain this is through the 5 stars of linked open data. We use these because publishing linked data is often an incremental process. You don't normally just publish linked data. You start off with your first star. And the first star of linked data is just to make the data available on the web in whatever format it comes in. A lot of organisations tend to hold on to their data and don't make it openly available. And if you've ever seen any of Hans Rosling's talks, he calls this database hugging. By making your data available on the internet, users can do a lot of things. They can view the data, they can print it, they can download it. The important thing when you make your data freely available on the internet is that you have some kind of policy. And this policy says, I give up rights to this data, I let you do whatever you want with it. And that's what the open data, linked open data is about. The next stage up from that is to make it available as structured data. By structured data, it would mean rather than, if you've got a table, rather than put the table on the web, put an Excel version of it on the web. If you've got a document that's full of text, make it available as a Word document rather than a PDF document. Now, if you do that, users can now not only access the data, but they can manipulate it, they can edit it, they can save it, they can annotate it, and they can search it. And they can also export it to different formats. The next stage along is to use open standard formats. By this we mean document types that don't require proprietary software. So if you've got a spreadsheet, rather than upload it as an Excel file, use a CSV file. If it's a Word document, upload it as a text document. Now you can see the first 3 stars are relatively easy to achieve. You don't have to do that much to get linked open data onto the web and available and get people using it. You don't even require a web service. So you can use things like WordPress and put the documents up there. And if you do that, more people have access to the data, and people will start to do interesting things on it, like build applications on top of the data. That's not to trivialise the importance of these first 3 stages, though, although they're quite easy to achieve. By doing these 3 things, you open up a lot more data to people. The 4th stage is where it starts to get a little bit more difficult. The 4th stage is about naming things, and in particular about using these things called URIs. URI stands for Uniform Resource Identifier, but it's just a technical way of saying a unique identifier for something. Now, when we publish linked data, we use the same type of identifiers that you use to navigate around the web. They're called HTTP URIs. So when you go on the web and you put in manchester.ac.uk, that's a type of HTTP URI. Now we say HTTP because that's the protocol that the internet uses. And if you use HTTP URIs, you can then look them up. So when someone looks up data that you've named using one of these HTTP URIs, someone can look up that HTTP URI and they can get information about it. Now, the 5th and final stage of publishing new data is this 5th star, and this is where the link bit comes in. So the 5th star is link your data to other people's data to provide context. And once you do that, you start having access to much more data. You can start making inferences along this new web of data, and it's at this point that the data becomes machine understandable. So, to give you an example of how linking works, if I have this thing here that I want to describe, as an example, I'm going to use this talk. So I would first, I've got this thing, I would add some attributes to it. So I would say it has a name, it's what is linked data, and it's like a talk. Now I might want to say something more interesting. I might want to say the talk is being held at the University of Manchester. So I can add this thing here and I can say it's being held at the University of Manchester. And what I've done here with these things is create what in the linked data world is known as a triple. And it's called a triple because there's 2 parts to it. So you have the first thing that I'm trying to describe, and this is known as the subject. At the end, you have the thing that I'm trying to link it to, and that's the object. And in the middle, the important bit is this held at, and this is what we call the predicate. And this describes the relationship between our subject and our object. And these triples are how the web of linked data is structured. So when you start describing things with these triples, you soon start to realise that, well, I'm describing the University of Manchester here. Someone somewhere else is also going to talk about the University of Manchester. I happen to know there's a place called DBpedia that talks about the University of Manchester. So I can say, the University of Manchester that I'm talking about here is the same University of Manchester that's held in someone else's data set, in this case. And I do this through this predicate here, which is same as. And this is the most powerful tool that linked data has. And that enables us to connect what we're talking about to what other people are talking about. Suddenly, when I create that connection, I have access to all the information that this person has about the University of Manchester. And similarly, if other people have got same as to this University of Manchester, I can get access to their data as well. So I can now say, well, I'm going to this talk at the University of Manchester. Can you tell me the location of the University of Manchester? Can you tell me what facilities are there? What other events are on that day? Could you give me a profile of the person who's giving the talk? And this is what the web of linked data looks like at the moment. You can see I mentioned DBpedia before, and that's this big blob in the middle. All these blobs are individual data sets. Arrows going between them are the individual linkages. You can see they all kind of converge on this central point, which is DBpedia. DBpedia is the linked data equivalent of Wikipedia. In fact, it takes data directly from Wikipedia. So DBpedia acts as a kind of hub. So if I'm looking at this particular data set here, the thing that I'm looking at references DBpedia. Also in this data set, someone else references DBpedia, the same thing. Not only do I have access to what DBpedia is talking about this thing, I also have access to what this person says about that thing. And that's where the power of linked data is. You suddenly open up access to a lot more information than you had before. So now that I've shown you what linked data actually is, I'd like to give you an example of how it can be used in research. And this is a real-life example. In 2009, a group of medical researchers set out to discover new drugs to treat Alzheimer's. And they had a question. And the question was, what proteins are involved in signal transduction and are related to pyramidal neurons? I have no idea what that means. But this was the question that they had. So they do what most researchers do, and they went to Google. And this is what they got. They got a lot of hits, but no results. And that's because no one had done any research into this before. So they decided to do a different approach, and they turned to the web of linked data, and they did the same query, they asked the same question. This time they got back 32 hits and 32 results. So they didn't have to sift through all those results to find that there wasn't actually any useful information there. And you can see that's what the power of linked data actually is. You can ask questions that haven't necessarily been asked before, and you can get back answers, and you don't have to go through and try and do a lot of the work yourself, a lot of the manual work. Now, I've used medical science as an example because there are many sources of medical data available. If I go back to the diagram, you can see all these data sets here to do with life sciences. And life sciences is probably the biggest single domain that has information available as linked data. But the social sciences are growing. At ESDS International, we've just published the World Bank's World Development Indicators as linked data. Now that's a fantastic data set. It's got over 1,000 indicators stretching back to 1960 with a great deal of information about international development. Other sources of social science data, data.gov.uk is the UK government's initiative to make as much data as it can openly available, and it's using linked data as its preferred method of doing that. And there are plenty of others. The Census Dissemination Unit, which is also based at MIMUS, we're looking to make the 2011 census data available as linked data, and that should be sometime next year. And Eurostat, Ordnance Survey, and lots of other data sets that are on there. So that's what linked data is about. It's probably worth saying that at the moment linked data is very much in its infancy, and the tools that are out there are not fantastic, particularly the tools for navigating and consuming data. But these are all things that are currently in development, and over the next few years you can expect to see more and more about linked data. And I hope you can perhaps see the vision that Tim Berners-Lee had when he described linked data and the semantic web. We're not quite there yet, but hopefully we'll be there soon. Thank you.